Hello dear students, welcome to ECE Academy Benefactor. In this class we will be seeing about sampler and mixer network in feedback amplifiers. In the previous class we have seen the block diagram of feedback amplifier. The other name of feedback amplifier is amplifier with feedback, or it is also known as closed loop network. So, let us quickly revise that block diagram. An amplifier of gain A, feedback network of beta A, B, feedback network of ratio beta, gain A, ratio beta, feedback ratio beta. At the input side of the amplifier we connect a mixer, at the output side of the amplifier we connect a sampling network. So, in this class we will be seeing about the sampling network and the mixer network of a feedback amplifier. So, why do we need to understand about sampler and mixer network is to do the analysis of feedback amplifiers. There are 4 types of feedback amplifiers we will be seeing in the next class. So, feedback amplifiers means it is having negative feedback. So, this is a schematic symbol of a negative feedback amplifier. An amplifier A, amplifier of gain A, feedback network of ratio beta, and a load resistor RL is connected. We are taking part of output and giving back to input. This is a mixer network. So, source signal plus and the feedback signal is minus. So, plus minus indicates that it is a negative feedback. XD means difference signal. The difference signal is source signal minus feedback signal. So, XS minus XF. So, here the difference signal is also known as input signal of the basic amplifier. So, what is the gain equation? Output by input. So, the amplifier gain is output is X naught, input is Xi. So, what is X naught? A times of Xi. So, how much feedback signal is taken? It is beta times of X naught. So, few important equations of negative feedback amplifier are difference signal is equal to Xi, XD is equal to Xi, and this X naught is equal to A times of Xi, output signal. And what is XD? XS minus XF. And what is XF? Feedback signal beta times of X naught. Okay, so before going to sampler and mixer network, we know this basic amplifiers are of 4 types. What are those 4 basic amplifiers? Voltage amplifier, current amplifier, trans resistance amplifier, and trans conductance amplifier, which we have completed also in our previous video. So, these are the schematic diagrams of voltage amplifier, and this is current amplifier, trans conductance amplifier, and trans resistance amplifier. So, what we are going to deal in the class here today in this class is about the sampling network and the mixer network. Sampling network is at the output of the gain amplifier, and mixer is at the input of the amplifier. Let us now see what is a sampling network, what is a sampler. So, there are 2 types of samplers, voltage sampling or node sampling. Voltage or node sampling. In voltage sampling, we are taking a part of output. Output is observed across load resistors, an amplifier of gain A, feedback network of ratio beta. So, this feedback network is connected in shunt to the amplifier output, at the amplifier output. So, this is known as voltage sampling. And the feedback network is connected in shunt across the output is known as voltage sampling. In current sampling, the feedback network is connected in series to the series across the output. So, this is a series connection, and this is the shunt connection. So, shunt connection is voltage or node sampling, series connection is current or loop sampling. So there are how many types of sampling are there? There are two ways to sample the output according to the sampling parameter, either voltage or current. When it is connected, when the feedback network is connected in shunt across the output, the parameter sampled is output voltage. When the feedback network is connected in series with the output network, the parameter sampled is current. So voltage is sampled and current is sampled here. Now coming to mixer network, there are two types of mixing. Mixing is done at the input side, series mixing and shunt mixing. Series mixing, when the feedback network is connected in series at the input side, series mixing. Voltage is, for series mixing we connect a voltage source. For a voltage source we need a series resistor Rs. So series mixing, series connection, this feedback network is connected in series at the input side. Series mixing, what's the source to be connected? Voltage. For shunt mixing, the feedback network is connected in shunt to the amplifier input. So when there is a shunt mixing, so we need to place a current generator of a current source Is with a parallel resistor, source resistor Rs. Okay, so this is all about series and shunt mixing. So there are few important equations before doing the analysis of feedback amplifiers. Let us quickly review those formulas and equations. That's the transfer ratio or gain. What's the gain symbol? A. So depending on the basic amplifier used, if it is a voltage amplifier, we say the gain is voltage gain. If it is current amplifier, the gain is current gain. If the basic amplifier is transconductance amplifier, its gain is GM, transconductance. For trans resistance amplifier, the gain is RM, which is known as trans resistance gain or trans resistance. So this is without feedback, we use the symbol AV. AV is voltage gain without feedback, V0 by Vi, output by input. Current gain without feedback, I0 by II. GM, transconductance without feedback, I0 by Vi. Trans resistance RM is equal to V0 by II. With feedback, so voltage gain with feedback, the symbol is now AVF. AVF is equal to V0 by Vs. Current gain with feedback, I0 by Is. Transconductance with feedback, GMF is equal to I0 by Vs. Trans resistance with feedback, RMF is equal to V0 by Is. So what is voltage gain without feedback? V0 by Vi. Voltage gain with feedback, AVF is equal to V0 by Vs. Okay, so these are the transfer ratio or the gain equations. You need to remember the formulas and the symbols. AV means without feedback, AVF means with feedback. Series mixing, shunt mixing. For series mixing, voltage source. For shunt mixing, current source. Voltage sampling, shunt connection. For current or loop sampling, series connection. Okay, so I hope you have understood the class. We'll see the how to draw each feedback amplifier in our next class. So till now what we have understood is the block diagram of the feedback amplifier, schematic diagram of negative feedback amplifier, and then what are the different basic amplifiers like voltage, current, transconductance, transresistance amplifier, and how to draw voltage and current sampling, series and shunt mixing, and the transfer ratio and gain equations. I hope you have understood the class. If you have any queries, you can post in the comment section. Thank you. Good luck, students.